this is our last presentation of the day, and it's great to see the room this full. Toby's going to be talking about moving from closed source to open source switch ASICs.
So, hi everyone. I'm Toby, coming from Berlin, working at this company. How many of you deal with actual hardware switches like ASICs? Oh, that's quite a few people. How many run open source software on them? Run. So you get packets through the pipeline in a way that you define it. So the agenda, I want to narrow down the scope a little bit in the beginning, and then let's have a look at what needs to be done by a networking operating system, and then let's have the whole 10-year through the history via the APIs and Gnosis, what's out there, what is actually open source and what claims to be open source, but maybe it's not. That's why the scope is as open source as possible. At least you should have an API and not needing to sign any NDAs to get actually the stuff running. Because most of the things are nowadays still like having an open API, which is quite great, like a huge step from that point of view in terms of access to ASICs, but even more still require an NDA that you get the actual software, that you can build your stuff yourself, and that's really not what we want to have here, right? So from what you need in terms of Gnosis ingredients, like you need, first of all, the hardware. This is the best thing what you want to have. You should build it your own, maybe have the Gerber files, have everything to solder it together if you like to. And actually that's possible nowadays. Like there's the OCP, the Open Compute project, that got handed in a lot of specifications, and you can go there on their specifications website and you can download it. Like there's the OCP is mainly driven by Facebook, but then later Google and several other big companies jumped onto that and brought their ideas in, specifications, and actually then some OEM switching vendors got into this as well and delivered the hardware. Like Facebook has its wedge switch, which is like fully documented there. You can get the files, you can even build it your own if you like to. Then the second part, which is like the part where I'm more or mostly talking about today, the open source software part, is actually like what do you need to actually run the system. You need drivers, you need the APIs at least, or maybe some SDKs are there, we'll see. So cutting a switch open or looking at a switch, and then you find some key components on this, like very boring, like power supplies, fans, and you have some temperature sensors on that. The switching ASIC itself, some embedded system, or nowadays even some Intel x86 CPU, which resides in there. You have a lot of ports, some management networks, and some management LEDs. You want to configure everything, and everything should work nicely together, that your switch doesn't burn because it's getting too hot, which may happen. One other thing is like that came up in the last years is disaggregation. It's a huge topic, sort of like. In former times, you had your switch driver, which was mostly closed, so each and every control plane software was basically very close coupled to that SDK. If you want to have a move to another hardware vendor, you would integrate this really specific to the other one as well. Nowadays, we want to talk more about common interfaces. We want to really see that we actually can use one control plane software on as many as possible hardware ASICs, and that's actually happening. And you even can take this common interface and have it in a way that the control plane software runs remote, and then your NOS may contain switch local software that's running on the embedded system, and your maybe centralized network operating system controller that's remote. So where this sort of happened. Well, there was SNMP at some point. Some people may still use it, but actually, like more detailed APIs were starting around 2001 when a working group at the IETF started the Forces working group. It's just like was very clean design. I'm not sure how many of you know Forces. 2, 3. So it's like they started with some informational drafts, like 2 or 3 in the very beginning, and then there was a long silence, or actually not having much in public, I'd say. And in between there was like something happening in Stanford in the US. There was like the Clean Slate program founded, and there were as well several researchers thinking the internet is broken and we need to fix it and deal with like some things, and they wanted to open up actually the hardware because they wanted to solve the problem very, very low down there. And one thing is very nice to look at is the ethane project. It was a very, very starting point for the Clean Slate program. There were people actually dealing with like 20 switches, central controller, kind of control plane, and it was somehow a starting point. You already read it, like for OpenFlow, and like with ethane and some actually vendors out there like Cisco, Deutsche Telekom Labs, and NEC. There was Xilinx as well, and some others in the very beginning that supported this idea. Likely dropped some money as well, and the whole Clean Slate program started. And one of the major outcomes was OpenFlow, which you may like or not, but it was like the first sort of thing that was trying to figure out how we can program the control plane, the data path from remote, or like you can run a controller as well on the switch if you'd like to, but the idea was to centralize everything, to get actually something like use of the centralized knowledge and make things better. So let's have a look at the APIs. OpenFlow was one of the first of them. It actually like sort of got off in 2008, then like with a paper from these researchers basically, and they presented at ACM SICOM the OpenFlow enabling innovation in campus networks, because they're where they came from and started in campus networks to really deal with actual people running their traffic through this network. So they got complaints and everything, and they had to make it running properly. The OpenFlow 1.0 release was made in 2009, and then closely afterwards there was a release of Indigo V1, which is like the OpenFlow 1.0 agent running on the switch, and mainly dealing with the TCAMs only. TCAM is like the most powerful kind of hardware that can do everything sort of down there, but it's quite limited. So it's like maybe a couple of thousands entries. If you can have a bigger one if you pay more, but like normally you have like a couple of thousand entries maybe. And excuse me. In 2012 there was OpenFlow 1.3 released, and Google announced, hey, we're running our network on OpenFlow. So they made it actually working for them. May not be like this Indigo control thing what was running there, but you get the idea. They took out the whole components running on the switches. They took the control plane to the central point. They made it high available, obviously, because otherwise Google couldn't run. And then they presented this to the world, at least the idea, right? In 2014, Broadcom released OFDPA. It's the OpenFlow Data Plane Abstraction. It's like, I think one of the things that sort of came out of this Google relationship, which was based on the TTP, the table type patterns in that came out as well alongside of the OpenFlow, which you're looking at here right now. It's the representation of the pipeline of the switch ASICs here in this specific thing, it was Broadcom's, and that's actually what was running on Google's hardware back then. They got rid of some bugs and I think mainly focused on layer 3 parts. I'm not 100% sure about that, but this actually is nowadays as well on GitHub. You find some binaries that run on several switches. You have the full API, several header files there, and you can actually run your own OpenFlow switch with this. Come back to this later a little bit. Then in 2014, like really open source, there was SwitchDev introduced. SwitchDev is actually Linux kernel's hardware framework for switching ASICs. So you have a common infrastructure that's residing in the kernel, and you have your hardware-specific driver that maps actually the patterns you want to have implemented to the ASIC and the south.
Sorry, Toby. You're showing F4 routing there on top of SwitchDev.
Oh, sorry.
To what extent is that a reality?
Basically, nowadays you can run anything on top what you can run onto Linux interfaces. So in the user space, you can run free-range routing. You can run manually your IP commands. Basically, what's happening here is that SwitchDev exposes some interfaces. Like you would create some tab interfaces, but they're SwitchDev specific. So everything what's happening there is really mapped down to the ASIC.
I kind of get that for something simple like an L2 bridge domain, or maybe something like IPv4 or IPv6 routing.
Exactly.
It's fairly straightforward. But if you get into something that's a little bit more edge, like something like failover or HA or ECMP or UCMP, does it have that degree of support yet?
I think ECMP is nowadays supported as well. I think I read something with VRP, these things, but
specific protocol is in kernel routing for a fairly long time, so you can configure routes like ECMP. I'm not sure about the failover though. I think there's something that you can do with like IPv4 and VLAN devices. I'm not sure. But like a lot of these things are actually in the kernel. The problem is just floating them, having the drivers that actually understand what you're trying to say.
That was more so my question. Maybe sorry, you should repeat the
So,
question for the camera. But does the SwitchDev have all of that kind of support to support the full richness of something like the free range routing?
yes. So the
You listen actually to like device events.
Yeah.
You know, somebody.
So in that sense, like SwitchDev is just presenting you, giving you the interface and everything what's happening up here in the user space, like what is configured, that's part of free range routing. So you don't offload anything off free range routing down here. So there's no logic map down here. This sort of static state. There's no intelligence in that sense, unless you have maybe something like ECMP. Then you have some hashing, some very very basic intelligence that does like what you actually want to have. And yeah, from the application point of view, this is like you write a netlink mapper or something like that. It's more advanced because you actually can run like ETH tool with this. So the actual interfaces are mapped down as well, as long as the driver supports this, obviously. I think SwitchDev was around kernel version 4.8 introduced, 4.2, and sort of usable at least for like one of the major driver or vendors that has this is Mellanox. At least for the bigger boxes. There's as well some smaller switching ASICs support from Broadcom and several others, but the really bigger ones are like Mellanox specific, and I think they're quite usable around kernel version 4.8. So let's go ahead and half time. SAI, Switch Abstraction Interface, was introduced in 2014. Anybody knowing this? Oh, it's getting less. Okay. It's a common set of interfaces. It's as well in the Open Compute project. It was contributed by Microsoft mainly. And it's sort of where health started freezing in the last couple of years because they really got open. And it started with 14 header files as of version 0.9, and now has 44 header files to actually like try to deliver an abstract interface that can be used to configure any ASIC below. Obviously needs some implementation. And in 2018, there was SAI Flex introduced. The major reason is because it's around the time where flexible ASICs were becoming more and more popular because there was this company in the US that drove this P4, so Barefoot in the end. Their ASICs are fully programmable, so this point of view of a static interface, which actually it was in the very beginning, it doesn't hold with standards anymore. I'm really interested how this will look like in terms of switch def, what we saw before, because that's like, yeah, as well quite static from at least the pipeline aspects and the primitives that you can call downwards to the ASIC. So then in 2015 there was OpenNSL introduced. Again, it's Broadcom that's opening up some other APIs. Actually, it's mainly their SDK. It's sort of driven by Facebook again because they're using this. I'll show you later, but they're using this API heavily. It's as well where Broadcom later on, so the next slides, delivers the SAI. But this is as well just a set of headers, very, very specific to Broadcom's ASIC. It's as well on GitHub. You find the binaries, the header files, etc., and you can program the ASIC with that. Now we're getting closer to today. It's 2017, and there was introduced P4 runtime. I just mentioned there's like this whole bunch of how I can program my ASIC now kind of thing. Actually, like this, it was introduced P4, and what Barefoot does with their Tofinos is it was introduced a little bit earlier because P4, the programming language what you will use, is like very powerful, and you can write your complete pipeline in that. And in the very beginning, there was I think a Thrift-based API and some other tools that you could use. But then a couple of years later, like in 2017, again Google came and said like, "Wow, that's cool, but we want to have it slightly different," and they presented together with them the P4 runtime. P4 runtime is not that something that actually deals only with this flexible ASICs. It's just an API. So it's a little bit confusing that the P4 name is there because that implies sort of you can deal with the flexible parts of a pipeline, but actually you can actually deal with the static pipelines with this as well. You just have to model your pipeline correctly, and then you just deal with the static one, because you will hand to the P4 runtime. You will hand some parts which is in the P4 info block. I'm not an expert on P4, but this is like what comes out basically of your P4 compiler. There's like the binary blob, what defines the ASIC, and there's the P4 info, which is sort of the contract between your data path and your control plane, and that's actually used in P4 runtime. And so if you model like if you have your model correct for the static pipeline, you can use this as well on static ASICs. Then in 2018, last year, Broadcom put SDK-LT on GitHub. SDK-LT is the first complete open source software from Broadcom, and you can deal with their Tomahawk chipsets. It's just for the Tomahawks, but it's completely there. Everything what you need is on GitHub. It's like, if you look at this is like really crazy what they thought out. They took a bit of a step to bring something up that's sort of comparable to the P4, because actually what you see here, that's coming like from your logical tables API. There's a transaction manager and the logical tables itself. The logical tables in the end are something that are like preparing for a programmable Broadcom ASIC in that sense, because like actually their ASICs are at least to some extent already programmable, but they don't give you that out yet, unless you're very, very big, I guess. This interface, what you see there on GitHub, will, like their next SDKs will be using that interface. And they're coming up with something that's called Network Programming Language, which is their counterpart to the P4 one, and this will define the pipeline that is used here. Almost through the APIs, because this year, this is a little bit look ahead, there will be Stratum. The Stratum project will announce or open source its works, which is currently happening in a sort of closed source manner on the GitHub to actually harmonize everything, bring in some ASIC drivers, etc., like SDKLTs there. There's currently written an adaptation to that. And this part here, what you see in the middle, which is partly the P4 runtime you saw before. And then there's GNMI and GNOI, which is coming from the OpenConfig project, which was as well started from Google a couple of years ago, which defines a lot of young sets and models that actually then define a gRPC interface that you can use to configure your pipeline or your switch in the end. So I think it's mid of the year, if I'm not wrong, when this will be completely open source. Anybody's like welcome to join the project. It's sort of like you contribute manpower and then you get access. So what's used anywhere here, like in terms of network operating system? And if you remember, there's something like you have fans, you have power supplies, etc., that you actually want to control as well. And in 2013, so we jump a little bit back in history, like we're done with the APIs, there was Open Network Linux released. And this picture actually coming from Big Switch because they contributed that partially, and it's now in GitHub. You can build your NOS. You have your platform abstraction layers. You have your kernel drivers, etc. It's everything is there. There are, I think, around 14 vendors that contribute their drivers and everything to that GitHub repository. That's as well in the Open Compute project. You can compile it, and you get an image that you actually can install. Anybody aware of Oni? I should have maybe explained it here before, but that's like the boot loader, sort of Pixie that you use to install an image to the switch itself. It's coming as well out of the Open Compute project, and so the image what is produced here is an Oni compatible image, and you can run it on the listed vendors switching ASICs. What you don't get there is actually the most important part, like OFDPA or OpenNSL or like any library that deals with the switching silicon. You just get the framework to run your Linux on the switch. So it's Debian based, so you can run anything what you want. Unfortunately, you don't get the important part from that project itself. But as I mentioned before, like on the Broadcom side, there are some binaries you actually can drop there. You just have to make sure that the version they mentioned maybe is correct in terms of what Open Network Linux uses. Plus, there's like all the others, just to name two, like Edge Core, Delta. They're having on their GitHub or company websites, they're having the drivers as well that you can put onto Open Network Linux. So you could actually start with something and write your own controller or network control application. Then I have here two examples of remote controls, like Open Daylight. It was like, I think, shown here before. I'm not sure if it was today. Anyone showing anything about Open Daylight? I'm not sure. And there was Onos presentation today, for sure. And these tools are really remote controlled, so you would run Open Network Linux on the switches to like deal with the fans, etc. And these are actually dealing with your network management. So I rush through them because I'm running late, sort of. And then there's FOSDEM, which I mentioned before. This is Facebook's open switching system. It's on GitHub. You get the agent. It deals with an OpenNSL API, so you need like OpenNSL from the one side, and FBOSS is on GitHub. You can compile it yourself. You drop it on your Open Network Linux or whatever you want to use, and run Facebook's system there. It was introduced in 2015. Has a Thrift API, and on top of that, nowadays there's as well a netlink listener, which used to be integrate, or well, there was a pull request that wanted to integrate that, but they put it outside and actually used a Thrift API. Then OpenSwitch was, I think, presented in the last couple of years here as well. OpenSwitch was started from HP in 2015. HP, I'm not sure what it was, but they went away from OpenSwitch. There are still sort of contributors there, but they handed it basically over to SnapRoute and Dell, but actually lies now at Linux Foundation. It's still developed. It has as well a Linux integration, which is in that sense just a netlink listener. It's sort of like, again, like SwitchDev, but you may create just like tab ports. I'm not sure, I'm not familiar with that in detail, but you get like 48 ports in your Linux that you can configure, and OpenSwitch takes care of applying this down to the ASIC. It runs on top of the SAI, what you've seen before, and it mainly supports Dell switches right now. Sonic, that's the part where I as well, like when the health rose, that's Microsoft's operating system. It's the software for open networking in the cloud. It runs as well on the SAI. It's has a very interesting architecture. There's some object libraries here that talk alongside Redis bus, and you have applications on top that you can choose to run or not, and that's very interesting. I don't go into details here. Look on the GitHub page. They have a very, very huge amount of documentation. It's very interesting. 2017, sort of, you run any distro with SwitchDev again. Like for Mellanox ASICs in particular, but like Fedora 25 you could run on the switch and have a network operating system. Or like, I'm not sure if anyone knows of Flatcar. There was last year a merge, or 2018 there was a merge request to enable the parts that actually enable SwitchDev. So you have the possibility to run your container Linux on the switch and deal with the network, right? It's sort of crazy, but a very, very clean approach, actually. I just listed these two distributions, but there's actually Debian, Ubuntu, and anyone else. I'm pretty sure they have support for this as well. So you can run actually for a certain subset of all these ASICs, you can run your own software. We actually do our software as well. We have a Yocto-based system. We take parts of Open Network Linux. We started with this when Open Network Linux was not that there yet, and we mainly did some like POCs and these things, but actually we're nowadays saying as well, like, actually we want to have an open source system. So you can look on the spacebooks.org site. It's currently based on the OFDPA code that's not open source. We have a netlink listener as well, so you can run free range routing on top. You can run it integrated, you can run it remote, or you can run Onos if you like that way more. Just take it. We have several images there that run on switches. We support a few right now, but we extend this in the next year as well. One more heads up. At the ONF Connect there was Danos shown It's basically an AT&T project that still lies internal, has to go through some legalization, but it's in principle a rewrite from scratch of the Vayata people's code, and the same people actually doing this. They're now at AT&T and want to open source Denos this year. So this will have like a full, in that sense, more telco-centric applications on board, but it looks very, very promising as well. So, a little bit of conclusion. There's like many ways to start things. Like you just have to find the right pieces. You can come to me and write me a mail. I can show you some things. Likely, it's easier then, but it's actually obvious. Two things are there that are fully open source, which is like Broadcom never thought this 10 years ago that Broadcom will actually open source something like that for their Tomahawk chips. It's like, wow, sort of crazy. And SwitchDev, just as well, really a really amazing thing. 1 second. And what I think is a little bit problematic is like these huge global players. We had heard Facebook, we had Google, we heard Microsoft. They're all doing their own thing. How would it be like if they would do something more together in that sense? But it's not happening. They even have like Open Compute Project, Open Network Foundation. There's like the organization is even separated. It's I hopefully have in the next 10 years we see something happening to grow these things together. But yeah, let's see. So now questions. Yep. I mentioned SDK-LT as fully open source, yes. No, it's fully open source, it's everything there. You can, you don't need any of these closed source parts, it's fully open source. Yeah, but in this case, no. It's as well something that was really like sort of shocking me as well. It's like it's really everything's there that you need to run on a Tomahawk ASIC.
Do you know if Cumulus Linux is embracing some open source part for the ASICs management, or it's proprietary tools?
I just know rumors, so I don't want to discuss this in detail, but I don't think so that this will happen soon, because Cumulus Linux, so the question was, is Cumulus Linux embracing some parts of this? I think they're in a state where they actually have a good running software, so it's hard to change this, but...
because it's managed by ex-Cisco guys, so maybe that they are still resistant to...
Yeah. Plus, they have investors, so it may be hard to change this to a fully open source system. So it's just guessing. It's really just guessing, but I would really like to see that.
Happy to put it there. If you have more questions for Toby,
yeah,
you can maybe catch him afterwards, or maybe at the Peace Cafe.
Yes, I'll be there.
Thank you so much for hanging out at the SDN room today, and if you've got
Thank you.